Hello, everyone, and welcome to our discussion for today. Our discussion for today is one of the most important real life applications of trigonometry, or in general in mathematics, which is the angle of elevation and depression. Now, once again, yes, it is one of the most important real life applications of trigonometry. What is angle of elevation and depression? Or actually, much better, let's separate the two. What are angle of elevation and angle of depression? Let's just say that this is you standing at the ground, and then there's like a certain wall. Now, in the wall, at the wall, there are two objects. Above you, you have a clock, and on the ground, but it's on the wall, you have a box. Now, let's just say you stared at the wall, like you look at the wall. So when you look at the wall, of course you're going to see it horizontally. Like if this is your vision, like from your eyes, you're going to stare at the wall as straight as you can. So here you you look straight at the wall. So it's perfectly horizontal. Now, what if your vision changed from that vision, which is looking at the wall, to the clock? Right? Like from wall going to the clock. So what happens is that if you tilt your eyes like going upward, what happens is you're going to change once again your vision from here going there. And because of that, there's an angle between the the vision you see on the clock and the vision you see on the wall, which is this one. Okay? Or it could be tilting your head just to look at the clock. The clock, like instead of doing like this, like my eyes from here going up, you can just tilt your head upward just to look at the clock. Now, what if let's go back on the scenario. What if yes, you stared on the wall, but you look down just to look at the box. So similarly, what happens is that your vision changes from from this vision initially to this vision where you look at the box. So from here going down. Okay, from here going down. So there would be also an angle here because that angle will tell you the like how much you rotate or you tilt just to see a different view. Now we have two angles here. If we have an angle that is above the horizontal line, which is this one, that is your angle of elevation. On the other hand, if you have an angle that is below the horizontal line, that is your angle of depression. I hope you get the difference between the two. Okay? So you look at the wall straight, then you look upward just to see the object above you. Expect that you'll be forming an angle of elevation. But if you look down just to see a box, expect that you'll be forming an angle of depression. Okay? So, according to the purple math, angle of elevation is also known as the angle of inclination, and angle of depression is also known as the angle of inclination. So here, just basically to summarize what I just said earlier, from whatever vantage point, angle of elevation is above the horizontal line, and angle of depression, from whatever vantage point, it is an angle below the horizontal line. Okay, below the horizontal line. Now, Here, I think you get the overview or preview here because we're going to talk about the angle of elevation and depression. So you may be thinking maybe we are looking for that angle, right? Because this is the topic. It's about angle of elevation and angle of depression. So I think the main topic here is to find those angles. If that is what you assume, then you are partially wrong. Because here, what if we have a given elevation or angle of depression rather, but you're going to find the distance between them, but in different direction or orientation. Or in other words, this is extremely useful not only in finding the angle, whether it's an angle of depression or not, but also in finding the missing side of the right triangle. So, for example, you have an angle of elevation. Like, yeah, this is your horizontal line. Then there is this line here, your diagonal line. So here you will have an angle of elevation. So what if you are tasked to find the height? What if? Also, speaking of what do you call this one, the sides. What if you're tasked to find the horizontal component, or basically this one? See? So here we're going to not only focusing in finding the angle, but also when it comes to the missing side of a right triangle. Okay? So, yeah, we're going to tackle this one in the future videos and now. All right? So, here in this video, now that I give you the idea of what is angle of elevation and depression, now what we're going to do is we're going to solve some examples of angle of elevation. Then the next video, angle of depression, and then the other parts that needed to be discussed by me. Okay? So let's start first with angle of elevation. So suppose there is a building that is 15 feet long and it casts a shadow of 15 feet long. What is the angle of elevation of the tip of building from the tip of the shadow? So let's just say that this is a building 50 feet long. So for a while. Yes. So this is 15 feet long. Okay? 50 feet. Okay. Then let's just say that uh suppose there is a light source here. For instance, a sun. Okay? So since the light source here is here located, which is top right of the building, expect that there is a shadow. Right? There's a shadow here. So that shadow is 15 feet long. Alright, that's 15 feet long. Now, our task is to find the angle of elevation of the tip of the building from the tip of the shadow. So, from the tip of the shadow, which is this one, going here, the tip of the building, you're going to find the angle of elevation, which is here. Remember, angle of elevation is above the horizontal. Okay? Above the horizontal. All right. So since this is the starting point or starting tip, which is the tip of the shadow, then going on the top of the building. So here, automatically, if you're going to find the angle of elevation, you're going to form an angle here, right here, as long as it is above the horizontal. Now, what are we going to do? So we're going to find that angle. Remember, this is a right triangle, so don't forget to put a right angle here. So let's cut the segment and let's get only the right triangle part, which is this one. Okay. So this is the angle, the right angle, 50 feet and 15 feet. Okay. So here's the thing. How to find the angle here? We're going to apply what we learned previously. which is the application of inverse trigonometric function. Remember, the usage of the inverse trigonometric function is to find the angle. So, thing is, what trigonometric function we're going to use for us to find the angle? Well, it depends on the given. So here in the right triangle, we have the hypotenuse, which is not given, but we have the legs that are given, which are the 15 feet long and 15 feet long. So if we're going to refer an angle here, because that's what we're looking for, now, which one is the opposite and which one is the adjacent? So your 15 feet, which is the shadow, the length of the shadow, that is your adjacent. Remember, if the side is beside to an angle that you're referring to, that is your adjacent. Okay? But for 50 feet, since it is not beside to that angle that we're looking for, that would be your opposite. Hence, 50 feet is your opposite side. Now, what are tangent or sorry, oh my god, I said it. What are trigonometric function that consists of a ratio of an opposite and adjacent? So there are actually two, which are tangent theta, because tangent theta is equal to the ratio of opposite to adjacent. And we have cotangent theta, which is the ratio of adjacent to opposite. So we are going to either use these two, or at least one of them. So for me, if you're going to ask me which one, well, I'm going to select the one that is the basic, which is the tangent theta. Remember in the previous video, I mentioned that if you're going to find the angle, just pick the three basic trigonometric ratios, which are sine, cosine, and tangent. The rest, it's up to you. But as long as you apply the basics, that is all that matters. Okay? Although you can use this one if you like to. So let's substitute. Let's find opposite. Let's find the angle here. So we have the opposite, which is 50 feet, and adjacent of 15 feet. So what we're going to do is we're going to put the tangent here. So we have theta is equal to arctangent of 50 feet all over 15 feet. So here, we're going to use our calculator. Like, let me just get my phone. My phone has a scientific calculator. So arctangent of 50 all over 15 at two decimal places, it is approximately 73.30 degrees. And that is our answer. That is the angle of elevation. It is 73.30 degrees. And that's it. All right. Now, you could use cotangent, okay? However, commonly in the scientific calculator, there's no such thing as cotangent, secant, and cosecant. Only sine, cosine, and tangent, which is why I mentioned that you would rather use the basic trigonometric ratios instead of the reciprocals in terms of finding the angle. Okay? So what if you use cotangent theta? Well, you have two choices. Either you search it in the Google or in the internet and find like a scientific or find a math calculator. And if there's a option where you can use inverse of cotangent to find the angle, that's good for you. Okay. Otherwise, you're going to do the second choice, which is the alternative for this one. Okay. So let me erase this one. All right. So basically, if you want to use cotangent by its alternative, you're going to use this one instead. If we have theta is equal to arccotangent of A all over O, you can just use this one instead. Arctangent of 1 all over adjacent all over opposite. So, in other words, instead of using this arccotangent of adjacent all over the opposite, just use this instead. I just use this one instead. Okay? So yeah, it's up to you. The answer will be still the same anyway. So That will be all for this example. Now, what we're going to do is we're going to proceed to the second example, which is this one. Imagine that there's a tiny hole in front of the house, and the distance between them is 6 meters long. If the height of the house is 14 meters long, then what will be the angle of elevation to the top of the house? So, hole is here, all right? Hole. And then let's just say this is a house. Oh, wait, no. Let me just fix this one. Okay. So, this is a house. There we go. So, the distance between them, horizontally speaking, it's 6 meters long. And the height of the house is 14 meters long. According here, you're going to find the angle of elevation to the top of the house. To the top of the house. So meaning, from this point of view to the top of the house, which is here, you're going to find the angle here. I here. Remember, angle of elevation is above the horizontal line. So which is this one. Which is this one. Now, what trigonometric ratio we're going to use to find that angle? If you're going to take a look closely in this right triangle, or at this part, at the part of a right triangle, your hypotenuse is not given, but the legs are given. The red line, which is your 6 meters, that is your adjacent because it is beside to the angle. And that 14 meters, that is your opposite since it is not adjacent to that angle. So with that, we're going to either use tangent or cotangent. But I'm going to use what I recommend you to use, which is tangent theta is equal to the opposite all over adjacent. So here, let's substitute. Your opposite is 14 meters long all over adjacent 6 meters long. Put tangent to the right, we will have theta is equal to arctangent of 14 meters all over 6 meters. So if you're going to use our calculator, our result would be in two decimal places. This is 66.80 degrees. That is your answer. 66.80 degrees. All right, that's it. Now let's have one more example. Suppose you have your car parked in a certain place. From your perspective, you see a plane going to a direction that is opposite to your car, where it is facing. At an instant, the distance between your car and a plane is 15 kilometers. If the angle of inclination from the car to the plane is 35 degrees, then what will be the distance between them horizontally and vertically? Suppose you have you have a car here, according to the example, and it's parked here, and it's facing to the right. Okay, according to your point of view, it's facing to the right. Now, there is a plane, and according here, the plane is going to a direction that is opposite to your car where it is facing. So that means if your car faces to the right, then plane here faces to the left. Okay, so it's facing here. Now, at an instant, the distance between your car and a plane is 15 kilometers. So meaning from here going there. Okay, from here going there. Right? From here going there. Wait, let me just fix the car. It's not that good. Let me fix it. Okay? All right, let me fix that. Much better if I would do it this way. But anyways, so this is once again 15 kilometers. Now, if the angle of inclination from the car to the plane is 35 degrees, so that means from the car to the plane, you have an angle of elevation. So from the car, starting from this car, You can now imagine that there is a horizontal line here. Okay? Imagine there's a horizontal line here. From the car. So here, we can say that there's an angle here, which is 35 degrees. Okay? Now, our goal is what will be the distance between them, the car and the plane, horizontally and vertically. So here, we're going to find the car, the distance between them horizontally. So from here, going until the plane. Okay? So from here, going here. All right? Then, it's, wait, no, no, no. Let me just erase the excess. There we go. And here, the vertical distance between them. So from here up, I mean from the car going the plane. Or you can rewrite it here. From here going to the plane. So we will find the red line and the blue line. Okay, the red line represents the horizontal direction and the blue line represents the vertical direction. So how are we going to do it? So remember last time that in a right triangle, let me draw it here. In a right triangle, let's just say your hypotenuse is given and the angle is given. If you wish to find your horizontal component, which is your x, you're going to multiply the hypotenuse by cosine. Okay? If you're going to find your x, multiply the hypotenuse by cosine theta, where the theta is the given angle itself. And if you wish to find the y, which is the vertical component, you're going to multiply your hypotenuse by sine theta. Okay? So if you want to find the horizontal component, you will multiply the hypotenuse by cosine 35 degrees. Okay? So with that, we have x is equal to 15 times cosine of 35 degrees. So approximately, if we're going to use our calculator, wait, hold on. This is approximately 12.29 kilometers. This is 12.29 kilometers. That is the horizontal direction. Now, for the vertical direction, the distance between the car and the plane, vertically speaking, you're going to use hypotenuse times sine. So y is equal to your hypotenuse 15 times sine of 35 degrees. So here, aha, okay, so here you will have approximately 8.60 kilometers. And those are your answers. There we go. All right. So let's take a break, guys. After this one, we're going to not discuss, we're going to answer some problems that involves angle of depression, right? Also, let me remind you that these examples, like this one, wait, these examples, they are just basics, okay? I just want you to get the idea how would you find the angle of elevation or rather angle of inclination, all right? At least in basic examples. Because after we know how to solve these examples, like the easy ones, the basic ones, then we can proceed to the other examples that are a bit challenging or intermediate rather. Okay? Because after we discuss the examples of angle of elevation and angle of depression, we're going to discuss other things about it, right? Also, in terms of answering some examples that are mixed. One is angle of elevation, the other is angle of depression, or both. Maybe our task is to find the angle of elevation and angle of depression. Okay? So, take a break, guys, and see you soon.